In the last segment, I introduced how to put elements together. I'll explain why we have two of these as we go along. And that the first thing you need to do is predict your ions and then make your pluses and minuses equal. So you were asked to complete these two. Calcium is a 2 plus, sulfur is a 2 minus, CaS. And like I said in the earlier segment, if you don't know how we get our ions, you need to go back to that material and keep practicing. Okay? At least 10 repetitions per topic at a minimum. Aluminum and fluorine. Aluminum is going to give away 3 electrons. Okay? So you can think of aluminum. I've got a new visual aid here. Okay, so I'm going to be aluminum, and I'm going to give away 3 electrons. Okay, and my fluorine here only wants 1 of these. Okay, so the question is, how many fluorines am I going to have to find? Okay, see they're bonded together. How many fluorines am I going to have to find in order to use up my electrons? Well, you're right. I'm going to need a total of 3. So let me look through my bucket here. You can hear me rooting around in the background. Okay, where do I find just plain blocks when I need them? Okay, so here's a fluorine. It's going to pair with this. Here's a fluorine. Going to pair with that. Okay, so I need 3 of them. And then this whole thing is bound together. And I get AlF3. Okay, I have 1 electron per fluorine. So I need 1, 2, 3 of them. Okay, so this is neutral. This is neutral, that's neutral. So what this is representing is the 3 fluorines, and then what this is representing is the entire compound. Okay, maybe that helps, maybe you like the pencils better. Nonetheless, you can see that when it's a subscript, it's all bound together. And what you want to do is you want to take it apart, okay, and you want to get your 1, 2, 3 fluorines back, and the original aluminum that donated these 3 electrons. Okay? All right. Then you were asked to come down here. All right? So 3 negatives means I need 3 sodiums, and what I end up with is Na subscript 3 N. Take it back apart so you see that you had to put 3 sodium ions and 1 nitrogen ion into it. We're going to come back to the name. This one is 1 plus, this is 1 minus, so we end up with KBr. And remember, when we break it back up, we're going to get this back. Okay? Again, if you're not practicing at least 10 times, again, you have examples in your book. You have your homework, you have your practice exams, you have your warm-ups. So this is part of the role of what the student needs to do outside of the classroom or online if you are online. Pause and don't go on until you have done this. All right, so here are a few more examples. Strontium +2, oxygen -2, SRO, barium +2, fluorine -1. We need 2 of them, so we get BaF2, aluminum and oxygen. You see this a lot. Okay, so let me go back to my visual aid. Let's say aluminum is a +3. Oxygen is a -2. You have to get your 3 and 2 to equal. All right? So let's say I'm going to add another oxygen. So now I have 2 oxygens. but I have 1, 2, 3, 4 minuses. 4 minuses, 3 pluses doesn't work. So I have to continue to find, see, I'm rooting around in my bucket here. So I'm going to find another aluminum. Okay, so here's an aluminum with a +3, here's an aluminum with a +3, so I have 2 of them. And I have 1, 2, 3, 4, 5, 6 pluses, but I only have 4 minuses. So now I have to round up another oxygen. Okay, so here's an oxygen, here's an oxygen. So what my visual aid is showing you is that I have 1 O2 minus, 2 O2 minuses, 3 O2 minuses. So I have 1, 2, 3, 4, 5, 6 pluses, 1, 2, 3, 4, 5, 6 minuses, and our pluses and minuses now equal. And this whole thing is going to bind together. Okay, so the whole thing is going to bind together. My big Lego tower. Okay, so it all binds together in one big block, and I'm going to write that as Al2O3. And when I take it apart, what I see is that I have, here's one aluminum that I started with, here's the other aluminum that I started with, here's an oxygen that I started with, here's another oxygen that I started with, and there's the third oxygen that I started with. Practice forward, backwards, forward, backwards. Okay, so now I'm telling you to try at least 20 of these. Okay, 20 of these. So there are tons. All right, so if you're using this book, here's at least 20 of them right here on this page. Page 186. Okay, it's asking for formula mass. We don't know that yet, but you can make the formula, and then we're going to calculate the mass of it. Okay, then once we make these compounds, then you have to name them. Okay, so it's like saying, oh, once I see this, I'm going to recognize that as a calculator, and I'm going to call that a calculator. Once I learn this, I call that an orange. Then I call this a coaster, right? So you have to identify the types and then give it a name. This is a fruit, this is a tool, this is a block of tile. So you need to understand what it's made of first in order to name it. So the very first thing that you have to do is you have to recognize an ionic compound when you see it. Okay? So what you should notice is that metals will form pluses. Non-metals form minuses. So generally, but not always, okay? Generally, but not always, you're looking for a metal and a non-metal. Okay? When you see a metal with a non-metal, it's likely to be ionic. If you see two non-metals together, that can't be ionic. Okay? So, first thing we want to do is look at this list. NaCl. Sodium is a metal, chlorine is a non-metal. This is likely to be ionic. Nitrogen and oxygen. Nitrogen and oxygen are both non-metals, so that one's not ionic. H2O. Hydrogen is not a metal. Oxygen is not a metal. KBr, MgCO3. Potassium, magnesium. Br, carbon and oxygen. So these are metals and non-metals. Okay, so these are likely to be ionic. Okay, So we're going to start with identifying those that are ionic and learn how to name these, and then we're going to come back to the ones that are not ionic and learn how to name those. Okay, so a couple more for you to try. AuCl3, PbOH2, and CaF2. Are those likely to be ionic or not ionic?